Hi, geometry students. I'm going to give you a brief introduction to similar figures. We're going to go over 2 pages in your notes. If at any point you need time to write down something I said and take notes, pause the video, and then when you're ready, just press play again. Add this to your word wall. Figures that are similar, and we use this symbol to go along with that, have the same shape, but not necessarily the same size. Similar polygons are 2 polygons whose corresponding angles are congruent and whose corresponding sides are proportional. In fact, what we were learning about dilations was so that we could talk about similar figures, because we could find a dilation that would move this triangle, triangle 1, to triangle 2. Triangle 1 is similar to triangle 2. You would write it like that. Triangle 1 is not similar to triangle 3. Notice that this changes shape. It's not the same shape. It can change size, but not shape. Here are 2 polygons that are similar. You'll notice that all of the angles, the corresponding angles, are congruent. They give us a similarity statement. That's what tells us which angle is congruent to which. So here I can tell angle A is congruent to E. Angle B is congruent to angle F. Angle C is congruent to angle G. And angle D is congruent to angle H. D and H. The order matters. The order tells us which angles are congruent. So I'm going to fill this in. Angle A is congruent to angle E. Angle B is congruent to angle F. Angle C is congruent to angle G. And angle D is congruent to angle H. Now, the sides are not congruent. However, they are all in the same ratio. That's what it means to be proportional. So if I take one side and divide it by its corresponding side, I should get the same number. You can tell which sides are corresponding based upon the order of your statement. You can see segment AB would correspond to EF. AB to EF, 6 over 12. Let me write that underneath, 6 over 12. BC corresponds with FG. BC, FG, 5.4 over 10.8. CD is here. That corresponds with GH, 4 over 8. And then finally, DA corresponds with HE. DA is 5, HE is 10. And you'll notice that all of those ratios, when I simplify them, all equal 1/2. So again, when we're looking at similar figures, all the angles are congruent, sets of angles are congruent, but sides are proportional in the same ratio. We can use the fact that polygons are similar to find missing pieces. So I like to give you one example before I give you some problems to do. We're given that this triangle ABC is similar to triangle DEF, and I'd like to solve for x. So notice that I'm given AB. That segment corresponds with DE right here. So I can write a ratio, 15 over 7. I'd like to find x, so I'm going to compare that to AC over DF, because those correspond as well. AB, big divided by big, equals small divided by small. These have to be in the same ratio. Now, in the problems that you just did, you should have seen that you can cross multiply to solve a proportion like this. So 7x is equal to 15 times 3, or 45. Then I just divide by 7. And it's not a pretty number, does not simplify, but that is the length, 45/7. Okay, so now I want you to try some problems. Have a great day.